can take recommendations, verbal data. Explanation data, theoretical data, verbal data, or recommendations. So what else? What type of data? We get statistical data. So anyway, any type of data under fuzzy can be modeled. And this is one, what I mean, a strong point in fuzzy modeling and in neural networks. Because in FEM, we need experimental data and theoretical data. But for verbal data, recommendation, suggestions, we cannot. But for fuzzy, we can make a mix of all this data. How we can model? Recommendation, suggestions, verbal data. Data comes from a formula, mathematical formula. Data come from experiment. That's why we call all of this data heterogeneous data. Heterogeneous data. Okay, not homogeneous, heterogeneous. Then fuzzy can form all type of data and form a model, and this data we call it heterogeneous. Heterogeneous means there is no relation between this data. Yeah, this just comes from experiment, and that one is coming from a mathematical model. That one from just do, don't do, don't do, and this one is just it will be good if you just increase up the speed. But yeah, by how much we don't know. Your suggestion, I suggest to just change slowly that bottom. So it is not what I mean precise data. It is not engineering data. But the idea of the fuzzy is how to convert all of this data into a decision. So we convert each type of the data into the common one. What is the common output? Common output is just fuzzy set. Okay? Fuzzy set means it's elusive set. You studied, I think, mathematics, and you know what is the definition of set. Yeah. Okay. Yeah, for example, set of natural numbers. 1, 2, 3, 4, 5, 6. Yeah. So, what is the commonality? What I mean among this set? It is a natural number. Okay. Yeah, natural number, and what I mean, it is not fraction. So we call it natural numbers. Okay, for that set, red, black, blue, white, and so on. We call it color set.
Color set.
Of course. Yes. But if we would like to form a set from this one, what is the name of that set? There is no relation between that set. Because this is the color set, this is natural number set, okay? This is complex number set, this is blah blah set, this is what I mean a Chinese set, Indian set, Iranian woman set, something like this, yeah. Because we have already have some attributes. But for that one, what is the common among this? We have experimental data, theoretical data come from model, verbal, recommendation, suggestions, and we would like to form a set. Then what is the common among this? That's why Dr. Fizada, he said, but this is a set which is not what I mean precise. It is elusive set. We call it fuzzy.
Fuzzy.
Yes. Means you cannot grasp it. You cannot grasp it. It is a fuzzy.
This is why the word is coming.
That's why the word is coming from the type of data. How you can put different type of data in a set. So the word is come as a fuzzy. Okay, anyway, and at the end we have to have output. That output is fuzzy output. It is just a degree of membership, which is between 0 to 1.
1.
Okay, that's why this step here is very important. Falsifications. Because in that step, falsification means we can unify the decision of the heterogeneous data, correct? Yeah, because here, if we enter, the output of this data will be just numbers from from 0 to 1, correct? And the input of such type of data, the output will be what? From 0 to 1. And also, if we have a membership in them, then the output will be what? From 0 to 1. Also here, a recommendation, the output will be from 0 to 1. So that's why it's called falsification. Now we already find a tool how we can take action from the heterogeneous data through the possibility theory, which is called falsification process. Okay? Yeah, this is that. And also here, the output. Output is just a fuzzy set, and we would like to take a decision, and we would like to have a physical value. That's why we need to go back. It is the inverse of falsification. The falsification is simply inverse of falsification. Okay, then one advantage of the fuzzy logic that we can model any black box theory or system. We can form up, we can mix different type of data. Okay. So we have some mathematics. What time now?
5.
5
sharp.
5 sharp. Okay, so we have some relations that you have to know. We call it fuzzy mathematical relations. Fuzzy mathematical relations. Fuzzy mathematical relations. Okay. And that's fuzzy mathematical relations. Yeah. For example, union. If one set and one set are going to merge together, what is the expression? Yeah, in normal set theory. Yeah, in normal set theory, if we have one set 1, 2, 3, 4, and 5. And we have another set, this is set A. And we have another set, which is set B. For example, 5, 6, 2, and 1.
All.
What is A union B? What is A union B?
All number 1, 2, 3, 5, 6, 7,
7?
Yeah.
What is 7? This is not 7, this is the bracket. Okay, 1. Then
5 to 1. Oh.
1, 2,
2, 3, 5.
yeah, 5, 6, okay? So, yeah. Good. This is the normal fuzzy set, normal union between sets.
Union.
But for fuzzy, we have to find a new expression. That's why Lotfi Zada, he found, what I mean, he tried to find a mathematical expression for the fuzzy relations. Now we have a crisp set, crisp mathematical set. And here we have a fuzzy set. And we would like to find what is the union and the intersection between the set. It will be same, like normal theory, or different? Same or different? Of course, different. Yeah, of course different. Okay, so that's why you have to know that title. We have 6 rules or 7 rules, very simple. Fuzzy mathematical relation. So we need the intersection, union, intersection, and complementary means A minus or B minus, the complementary set. Most important, most important is union and intersection. fuzzy, simply we take it max.
Max.
Yes. Just look at the numbers in all the sets and get the maximum value. That's all. So we take max. Max A and B. So if we have two fuzzy sets, A is a fuzzy set and B is a fuzzy set, and we would like to take union of this set. So the union of the two sets together, just look for the highest degree of membership in these two sets. This is, we call it the union of A and B. This is in fuzzy. Okay? And intersection. So intersection. What do you expect?
Mean.
Yeah, minimum. Very simple. Minimum, of course. Minimum. So, minimum. Okay, what is complementary? Meaning if we have that fuzzy membership, that fuzzy set, and we would like to find the complementary. It is -1 or just dash? Dash. Dash. Okay. Complementary means element which is not exist in A and exist outside the A. So the complementary in fuzzy, the expression is just 1 minus A. Yeah. 1 minus A. After finding the maximum or minimum, and 1 minus 1 gives the complementary. Okay? Yeah. Anyway, most important for you to know just how the intersection and how the union of two fuzzy sets are done on the computer. It is done by simply the maximum function and the minimum function. So it is a very small subroutine, searching for the maximum value between A and B, and searching for the minimum value between set A and set B. Then we can find the intersection between A and B. Why we look for the other one? Because simply, as I told you, we want to form a rule, for example. We want to form a rule. So if we are going to mix, here for example, if lubrication is L, and lock, and if lubrication is L, and speed is M, so we still want to know what is mean by and. Intersection, correct? So now, when we are going to write in the rule, if oil or lubrication is low, or speed is M, then what is the expression of or? Yes, correct. Then and or. Then now we are going little bit by bit how to interpret the rules. Then and means intersection. And or means union. So this is very simple here. This is or. When you see or in the rule, so this means we have to make max between sets. When we see and, we have to make minimum, or we have to make intersection. Okay. So in a rule, it's just consisting of this: if, and, or, then. Okay. So the most important expression is or and or. How the computer can interpret it in a mathematical fuzzy way. Here this one. Okay. Maximization, minimization, and fuzzy set already formed here. Then we can find Okay, we can take a decision and between the rule. Okay, I think fuzzy is very simple, but can do a lot. So after praying, I give you a working example. So you have MATLAB already here.
Already.
You have it?
But the fuzzy,
It's not installed.
I just check first because
Okay, just try to ver.
there's only MATLAB.
Dia keluar balik ni. Dia start balik.
Go to the command, go to fuzzy,
Yeah.
and write ver.
You kan ni. Lesson.
Because during installation,
So you already know fuzzy, how to use it.
Oh, kan ni.
You know.
Lesson tadi, lesson.
You know how to use fuzzy logic toolbox?
Lesson barang bro.
Okay, type fuzzy. Okay, good. So
Kat mana kita start dia?
Tak. Mana kau letak saya?
MATLAB.
Correct.
Ni, correct. Ni, standalone.dat. Next. Ada, finish eh? Ada.